In question 6, we're asked to differentiate the function from first principles. As in previous questions, I start by drawing out a generic curve, and I start with a standard coordinate of x squared minus 12x plus 10 as a y-coordinate. Then I move an extremely small distance along the x-axis called delta x, and then I create two new coordinates, which is x plus delta x, to take into account that movement. And the y would be x plus delta x squared minus 12x plus delta x plus 10. What we would do now, as in most C1 coordinate geometry questions, is just look at the gradient, which would actually be denoted in this case as delta y over delta x, to take into account that small movement of delta x, giving a small movement of delta y. There's been the change in the y coordinates over the change in the x. So change in y would be x plus delta x squared minus 12x plus delta x plus 10 minus x squared minus 12x plus 10 all over our small movement across the x-axis delta x. The next stage obviously is to expand the numerator out. So delta y by delta x is equal to x squared plus 2x delta x plus delta x squared. The expansion of x plus delta x all squared is something that you really should commit to memory. Minus 12x minus 12 delta x plus 10 minus x squared plus 12x minus 10 all over delta x. We're now left with that fairly daunting numerator, but then on second glance we can see the x squared and minus x squared cancel, minus 12x and plus 12x, plus 10 and minus 10. So then we can see we end up with 2x delta x plus delta x squared minus 12 delta x all over delta x. At this stage you should realise that delta x is common in every term, so we can divide through by delta x to give us 2x plus delta x minus 12. The next stage is to state what would happen if delta x was reduced till so the distance was basically going to be 0 or approach 0, and we must state mathematically that obviously we're setting that as delta x approaches 0. Our function becomes 2x minus 12 because the delta x becomes insignificant. Therefore dy by dx is equal to 2x minus 12.